Hello everyone, and welcome to 35 Minutes Python Crash Course. In the next few minutes, we're going to learn Python. However, to take this course, you should have basic programming knowledge as it is only a crash course. Let's start with the question, what is Python? Python is a high-level interpreted programming language created by Guido van Rossum in 1991. It's designed to be easy to read and write, with a syntax that emphasizes code readability. Python's clear syntax makes it great for newcomers to programming. However, despite its simplicity, it's a very powerful language as it is one of the leading languages to be used in artificial programming field. So now, let's start learning Python by coding in it. Basic syntax and data types. Before talking about basic syntax and data types, let's talk about indentation and code blocks. You might know in other languages we use curly braces to group code together. However, in Python we implement things a bit differently. Here we use indentation. It does not only make the code look pretty, but it's how Python understands the structure of the code. Let me show you what I mean. Here I have an if statement. It's just for an example. We'll learn about if statements later in this course. You can see how lines are indented here. That's how Python knows which lines belong to which block of code. It's usually 4 spaces for each level of indentation. Now, let's chat about comments. Comments are like little notes we leave in our code. They're super useful for explaining what our code does, both for ourselves when we come back to it later, and for other people who might read our code. In Python, we've got 2 types of comments. For one-line comment, we use the hash symbol, but if we need to write a multi-line explanation, we can use triple quotes. Python ignores these comments when it runs the code, but they're incredibly helpful for us humans. Now, let's talk about variables. In Python, creating a variable is very easy. You just need to type variable name and assign a value to it. As Python's pretty smart, it figures out what type of data you're using based on what you assign to the variable. You don't have to tell it, hey, this is a number, or this is text. It just knows. Now, let's talk about data types. There are quite a few, but we'll cover the most common ones. First, we've got integers. These are to handle whole numbers. You use them for counting things or doing math without decimal points. For example, here, age is an integer. You can do all sorts of math with integers, like addition, subtraction, you name it. Next, we have floating point numbers, or floats for short. These are for decimal points, like for precise measurements. For instance, this height variable is a float, probably representing someone's height in meters. Then we have strings. Strings are for text, anything from a single letter to a whole book. You create them by putting text in quotes. You can use either double quotes or single. Strings are super versatile. You can combine them, split them up, change them to upper or lowercase, and lots more. Then come the booleans. They're simple but powerful. They're either true or false. You use them for yes or no situations, like, these are great for making decisions in your code. Now, let's talk about some more complex types. First, we have lists. Think of a list as a container that can hold multiple items. Lists are ordered, which means you can access items by their position. They're also mutable, meaning you can change, add, or remove items after creating the list. Similar to lists, we have tuples. They're like lists, but with one big difference. Once you create a tuple, you can't change it. They're immutable. You might use a tuple for something like coordinates or something like that. Last but not least, we have dictionaries. These are super useful when you want to store information in key-value pairs, like this. Here, name and age are the keys, and Alice and 30 are their respective values. Dictionaries are great for organizing related data. And there you have it. These are the basic data types in Python. Each one has its own uses and methods, and as we go on, we'll dive deeper into how to work with each of them. Now we'll explain operators along with data types. These are the tools that help us manipulate our data and make decisions in our code. First, let's talk about arithmetic operators. These are probably familiar to you from math class. Arithmetic operators work primarily with integers and floats. In this example, we declared these 2 integer variables. We can perform addition, subtraction, multiplication, division. There are some advanced methods like exponents, floor division, and modulus. Some arithmetic operators also work with strings. Like addition operator is used to concatenate strings. We can also use multiply operator to generate string to define number of time. Next are the comparison operators. Comparison operators work with all data types and are used to compare value. These always return a truth or false Boolean value. For example, this equal to operator returns true when both values are equal. Not equal to operator returns true when values are not equal. Greater than operator returns true when is greater than b. Less than operator return true then is lower than b. Greater than or equal to operator return true when either is equal to b or greater than b. Less than and equal to operator returns true when either is equal to b or is lower than b. Comparison operators are super handy in if statements or loops when you need to make decisions based on comparing values. Next are logical operators. Logical operators work primarily with booleans. These are used to combine conditional statements. For example, we created two variables and passed boolean value to these. First, we used an operator. An operator is like a strict teacher. It returns true only if both conditions are true. Then we used or operator. It is less strict than an operator. It returns true when at least one condition is true. Finally, we used not operator. It acts like a rebel. It always goes against the policies and flips the given boolean value. All these operators are the building blocks for more complex operations and decision-making in your Python programs. Now we'll talk control structures. These are like the brain of a program. These are the tools that let us make decisions, repeat actions, and control the flow of our programs. First, we'll talk about if statements. If statements are used to make decisions on conditions. For example, we declared an integer variable named temperature and passed it 25. Then we used if statement, and in condition we checked if temperature is above 30, then run this block of code. Then we used elif statement. It is short for else if. In condition we checked if temperature is above 20, then run this block of code. At last we used else statement. It will run only if conditions do not match in if and elif blocks. In our case, elif statement is true and that code block executed. We used elif statement just to show you. You can use if-else statements, or you can also use just if statement. Next are for loops. For loops are great when you want to iterate over a sequence like a list, or when you want to repeat an action a specific number of times. For example, we created this list named fruits and passed some items to it. Then we used for loop and created fruit property. You can name it anything, and used in keyword to pass fruits list. It means run this for loop as many times as the length of this list. Inside it, we used this fruit property to display the items from the list. You can also run for loop without using any list. For example, we used this range method here and passed it the value of 5. Now it will run 5 times. Next are while loops. While loops keep running as long as a condition is true. They're great when you don't any prior knowledge about how many times you need to repeat the loop. For example, we created this count variable. Then we used while loop and set the condition to run the loop till count is less than 5. Inside it we printed the count and also increment 1 to the count variable. You can increment 2 or any value you want. Important thing is that if we don't increment the count, then this loop will run for infinity or till system crashes. This loop run till value is less than 5. Next are break and continue statements. Sometimes you need more control over your loops. That's where break and continue come in. For example, we created this for loop to run 10 times. But inside it, we used if statement to check if value is 5, and inside it we used break statement to stop the loop and come out of it. And then we are simply printing the value. This loop run till the value reached 5 and did not run after that. That break keyword broke the loop. Then comes the continue statement. Here we created another for loop. Inside it, we used if statement to check if value if 2. Inside it we used continue statement. It will skip the execution of the code under it and will move to next iteration. This loop has run 2 times and skipped code execution of 3rd iteration after continue statement and moved to 4th iteration. Next are match statements. If you're coming from languages like Java or C++, you will surprised that there is no switch statements available in Python. However, in version 3.1 Python introduced the match statement. The match statement is more powerful than a traditional switch. It can match against literals, multiple values, and even complex patterns. For example, here we created this grade comment method here which takes grade as parameter. Inside it, we created match statement and passed grade as condition to it. Inside it, we used cases to check grades, and we also returned message inside each case. We also passed multiple value in this case here. Finally, we created default case to be executed if no value matches. Then we called this method and passed grade parameters. It returns the message according to the passed grades. And that's all for control structures. Now we'll talk about functions. Functions are like little machines that do specific tasks. Functions are used to organize the code, make it reusable, and save developers from writing the same code over and over again. First, we'll talk about defining functions. In Python, we define a function using the def keyword, followed by the function name and parentheses. For example, here we defined a function using def keyword and named it greet. Inside it, we are simply printing a message. To use this function, we simply have to call this method. We can call this method multiple times to get the output without writing the same code over and over again. Now we talk about parameters and arguments. Parameters are the variables which are defined in the function on declaration time, while arguments are the values which are passed to the function on time the calling that function. For example, here we define the variable named person name, then are called that function and pass this Alice name to it. This name or value is the argument. Functions become really powerful when we get the ability to pass the information to them. Parameters and arguments give us that power. We can also pass multiple parameters to a function. For example, Here we defined a function and declared two parameters named person name and programming language. Inside it, we are simply printing these parameters. Then we called this function and passed two arguments to it. Here first argument will be assigned to person name variable and second argument will be assigned to second parameter. After running it, you can see that both arguments are printed. We can also define parameters with default value. It means that if we don't pass any argument to that parameter, it will use its default value. For example, here we created a function and declared two parameters named name and greeting. Here we assign default value to greeting parameter and not to name parameter. Also, parameters with default values should be assigned after parameters which do not have any default value. Inside it, we simply displayed the message. Then we called this method twice. First without any providing argument to greeting parameter, while second time, we provided argument. After running it, you can see that first time it used default greeting value, however second time it used the value of the argument which we passed. Next topic is how to return data from functions. So far, our functions have just been printing things. But functions can also return values, which we can then use in other parts of our code. We do this with the return keyword. For example, here we created a function and declared two parameters of it. Inside it, we used return keyword to return the value, and after that we performed addition to A and B using addition operator. Then we created result named variable and initialized it with this function and passed arguments to it. Then we simply printed this result variable. After running, it printed the value after adding both arguments. Let's see what happened here. Once we pass this method to result variable, then whatever value this function will return, it will be assigned to result variable. We can also call this function inside other operations or methods. Like print is default method in Python. Inside it we can call this add function. We can also perform other operation with it. Like we multiplied it with 3. Here, whatever value this function will return will be multiplied by 3. Now we'll talk about some built-in functions in Python. First of all, we'll talk about print method. We've been using it throughout this course. This method is used to display the text or data inside console. It is also very handy while debugging. Next is len method. It returns the length of an object. That object can be string, list, or something else. Next type method. It returns the type of the object. Like here it shows that values are of int and string types. Next are float, int, and str methods. These methods are used to convert the data type of the given values. Int convert the values to integer type. Float convert the values to float type. And str convert the value to the string type. And finally, input method. It is used to get user input from the console. Inside it, we can pass the display message to let user know about what type of answer is required. Like here we are asking for the name. Also we assign this input method to this name variable. User input will be stored in this variable. Then we printed the name variable. Now we need to run it in terminal. So, run it in the dedicated terminal. Now program is waiting for user input. So enter the name and press enter. It printed the username we entered. These are just basic built-in methods. There are tons of methods which you'll learn in your Python journey. We learned about lists and dictionaries in the data type section. Now we'll talk about both in detail. First, we'll learn about lists. Lists are ordered collections of items in Python. They can contain any data type, and you can mix and match types within a single list. To create a list, we use square brackets. We can add items of multiple data types inside it. Let's talk about accessing the list. First, to access the specific item of the list, you can pass the index of that item using brackets like this. It will return only that particular item from the list. An important thing to remember is that lists are zero indexed, meaning the first item is at index 0. So, always remember that the first item will be on index 0. We can also access the list items using negative indices. For example, -1 returns the last item of the list. We can further increase the value to access more items in descending order. We can access items of the list using a range like this. It returns the items between that range. Now, let's talk about the list methods. The first method is the append method. It is used to add new items to the list. New items will be added at the end of the list. Like we added this item to the list. Next comes the insert method. It is used to insert new items in the list on specific positions or indices. Like, we added this item at index 1. Next comes the remove method. It is used to remove a specific item from the list. Like, we want to remove this item from the list. But remember that it only removes the first occurrence of an item, which means if the item has duplicate values, then it will only remove the first item. Next comes the pop method. It is also used to remove items from the list. You can pass the index number to it to remove specific items. But by default, it removes the last item of the list. This pop method also returns the last deleted item. So, we can store it in a variable, and then print that item. Like, here is the deleted item, and this is the updated list. We can use the len method on lists to get the length of the lists. Like, right now, our list has 5 items, so the length is 5. Next comes the sort method. It is used to sort list items. For example, we have this list of unordered numbers here. After using this sort method, list items are sorted in ascending order. And finally comes the reverse method. It is used to reverse the items on the list. Like, after using it on our list, items of our list are reversed. These methods allow us to manipulate lists in various ways, making them incredibly versatile for storing and organizing data. Now, let's talk about dictionaries. While lists are great for ordered collections, dictionaries are perfect for those who want to store data in key-value pairs. We create dictionaries using curly braces, with key-value pairs separated by colons. Key comes before colon, and value comes after it. We can fetch value using its key by putting it inside the brackets. We can also fetch the values using the get method. It returns the value, but the benefit of the get method is that we can specify a default message or value if the value is not found, as there is no job key in the dictionary. So, it returned the default message. Now let's talk about dictionary methods. First comes the keys method. It returns the view of all the keys of a dictionary. Next comes the items method. It returns all keys and values in key-value pairs. Next comes the update method. It updates the dictionary with elements from another dictionary or an iterable of key-value pairs. Like here, it added the new job key-value pair and updated the age. Next comes the pop method. It removes the item with the specified key and returns its value. Like, here is the removed age key-value pair and the value of the removed key. And finally comes the clear method. It removes all items from the dictionary. Like here, it removed all key-value pairs. One cool thing about dictionaries is that they can contain complex data structures as values. For example, we could have a dictionary where the values are lists. Like here, we stored the lists as values inside the dictionary. We can fetch the item of a list from the dictionary like this. However, we can also fetch the specific value from the list using the item's index after the key, like this. This flexibility makes dictionaries incredibly useful for organizing and structuring data in Python programs. With this, lists and dictionaries are complete. We learned about input method in functions section. Now, we'll learn about input-output and string formatting. First, let's talk about input method. The input function is your go-to tool for getting information from the user. It displays a prompt to the user, waits for their answer, and then returns what they typed as a string. For example, here we declared name variable and assigned input method to it. We asked for username inside input method. Then we used print method to display the input method. Now if we run it in terminal, it will wait for user input. And once user press enter, it will display the output. One important thing to remember, input method always returns a string. If you need a number, you'll have to convert it. For example, here we created an age variable and assign it input method to get user age. Then we used the type method to get the data type of this variable. Then we created new age variable and assigned the int method to it and passed it age variable to it. This int method will convert the user input into integer format. And finally, we printed the new age variable. Now run it and type the age. Here we can see the data type of age variable is string, but data type of new age variable is int. However, if user types wrong input, then it will return an error. For these types of exceptions or errors, you need to use try-catch blocks. We'll talk about these in next section. We've been using print method all along, but let's dive a bit deeper. The print function is incredibly versatile. Here are some incredible features of it. We've been printing output using like this. Then comes printing multiple items. Here we declared 2 variables. Then we used print method. Inside it, we used this F letter before string for string formatting. Then we can use curly brackets to display the variable inside the strings. As we can see that values of the variables are displaying. Then comes the separators to the strings inside the print method. Here we created multiple string inside the print method. Then we used sep property of print method and passed separators in string format to it. In output, you can see that it separated each string with given separated. And finally, comes the end property. Here we created two print method and to display hello world message. After running, both messages are displayed in two separate lines. To prevent this, comes the end property. Here we created two print method again, but we used end property in first method and inside it we provided single space. After running it, both messages are displayed on same line. You can also assign any variable or any symbol to the end property as you need. Next comes the string formatting. String formatting is extremely useful to display the variables inside the strings. For string formatting, we use F letter before the string. Like here we created print method and used this F letter before string. It allows us to display variable or to include the expression inside the string. Like, we use this addition operator here to add both variables. With this section is complete. Now, we'll talk about modules in Python. Before writing code, what are the modules after all? In Python, a module is simply a file containing Python code. It can define functions, classes, and variables that you can use in your own programs. Modules help organize code by grouping related functionality together. Python comes with a large standard library of modules, and there are thousands more you can install from the Python package index. These modules can do everything from mathematical operations to web scraping to game development. Now, let's check out how to import and use modules. There are several ways to import modules in Python. First way is to import the entire module. Here we imported the math module. Here we use the pi and square root methods from the math module. There are so many methods in each module for you to use. Second method is to import specific items from a module. To import specific items, we need to use from keyword and module name. Then we use import keyword to import packages, and then mention the names of the methods to import. Like here, we needed only pi and square root methods, so we imported only these methods from math module. And in print method, we directly use the method names to access it. Next method is to import the module with an alias. To prevent rewriting the module name again and again, we can import it using an alias. Like here we imported this math module as just m letter. Inside print method, we can use this m letter to access all methods of the math module. Now, let's see some commonly used modules code examples. Math module is used for math-related calculations. Random module is used generating random numbers. Datetime module is used for datetime related functionality. You can also install external modules. To install modules, you can use terminal or CMD. Then type pip install and then add module name. We want to import requests module which used for making HTTP requests. Once installed, we can now use this module inside our code. To uninstall a module, type pip uninstall and type module name. These are just a few examples of the many modules available in Python. Each module opens up new possibilities for what you can do with your code. That's all for this section. Now, we'll talk about exception handling. Exception handling is how we deal with errors and unexpected situations in our code. The basic structure for handling exceptions in Python is the try except block. Like this. In try block, we try execute the code which might raise an error, and in except block, we handle the error or exception. In this example, we're trying to divide by 0, which would normally crash our program. But with the try/except block, we catch the error and print a message instead. Then our program continues to run. However, using a bare except clause like this isn't recommended. It's better to catch specific exceptions, which brings us to our next topic. Python allows us to catch specific types of exceptions. This is generally a good practice because it allows us to handle different types of errors in different ways. In this example, we're getting user input and handling the exceptions that might occur. Now, if the user enters something that's not a number, like if we enter a letter here, then we'll get a value error. Next is zero division error. It will occur if we try to divide the value with 0. The final except clause catches any other unexpected exceptions. Then comes the else and finally clauses. We can also use else and finally clauses with our try/except blocks. In this example here, we used the else block, and after that, we used finally block. The else clause runs if no exception was raised in the try block. The finally clause runs no matter what, whether an exception was raised or not. It's often used for cleanup operations. Next comes the raise exception method. Sometimes, we want to raise our own exceptions when something isn't right in our program. We do this with the raise keyword. In this example, we created this function with age parameter. Inside it, we used the if statement to check if the age is less than 0. And then we raised the value error exception. In try block, when we call the function with -5, it raises the exception, which we then catch and print. Next are the custom exceptions. While Python provides many built-in exceptions, sometimes we need to create our own for specific situations in our programs. Here, we've created a custom negative age class with exception parameter, then raised the negative age error. After that, we called this function in try block and then handled the custom negative age exception. After running it, we can see the custom error message. That's all for exception handling in Python. Now, we'll talk about file handling in Python. So, let's begin with opening and closing files. The most basic way to open a file in Python is using the open function. The open function is the gateway to file operations in Python. It takes several parameters, but the two most important are the file path and the mode. In our example, example.txt is the file we want to open, and arn means we're opening it in read mode. This function returns a file object, which we're storing in the variable file. It's crucial to close your files when you're done with them. This ensures that all your data is properly saved and that you're not wasting system resources. Always remember to close your files. But what if you forget to close the file or an error occurs before you get to the close statement? That's where the with statement comes in handy. This with statement is like a helpful friend who always remembers to close the door behind them. It automatically takes care of closing the file for you, even if an error occurs. It's the recommended way to work with files in Python because it's both cleaner and safer. Now that we know how to open files, let's look at how to read from them. There are several methods we can use. Let's start with the read method. The read method is like a vacuum cleaner for your file. It sucks up all the content at once and returns it as a string. If you add a number in the parentheses, like 10 to read method, it'll read only that many characters. Be careful though, if you use read on a huge file, you might run out of memory. Next, let's look at the readLine method. Think of readLine as a polite reader who only reads one line at a time. It's great when you want to process your file line by line. If you call it again, it'll read the next line, and so on until it reaches the end of the file. But what if you want all the lines, but still separated? That's where readlines comes in. The readlines method is like a librarian who hands you all the lines of the file neatly organized in a list. Each item in the list is a string ending with a new line character. We're using strip method here to remove any extra white space, including that pesky new line at the end of each line. Now, here's a pro tip. This method treats the file object itself as an iterable, reading one line at a time. It's like a conveyor belt, delivering each line to you one by one. This is super efficient, especially for large files, because it doesn't load everything into memory at once. Alright, we've covered reading files. Now let's talk about writing to files. The simplest way is using the write method. The write method is like a pen. It writes exactly what you tell it to. Notice we're using wt mode here, which stands for write. Be careful with wt mode. It'll create a new file if one doesn't exist, but if the file does exist, it'll overwrite everything in it. If you want to write multiple lines at once, you can use write lines. Despite its name, write lines method doesn't add new line characters for you. You need to add them yourself if you want them. It's like a printer that prints exactly what you give it, no more, no less. Finally, let's talk about appending to files. What if you want to add to a file without overwriting what's already there? That's where a mode comes in. Then to mode is like a friendly bouncer. It lets your new content in and puts it at the end of the line. If the file doesn't exist, it'll create a new one. This is great when you want to add new data to a log file or continue writing where you left off. Remember, always use the with statement when working with files. It's like having a responsible friend who always cleans up after themselves. With that, file handling section is complete. Now, we'll talk about object-oriented programming in Python. Let's start with what is object-oriented programming. At its core, object-oriented programming is a programming paradigm based on the concept of objects. In it, you model your program using classes and objects. A class is a blueprint or template for creating objects, while an object is an instance of a class that represents a specific entity. Object-oriented programming revolves around four main principles: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation is the practice of bundling the data and methods that operate on that data into a single unit, known as an object. It also involves restricting direct access to some of an object's components, which is why it's often said that encapsulation helps to hide the internal state of an object. Inheritance allows one class to inherit attributes and methods from another class. This reduces code duplication and promotes reusability. Polymorphism means many forms and refers to the ability of different classes to be treated as instances of the same class through a common interface. In simple terms, different objects can respond to the same method in different ways. The abstraction principle focuses on hiding complex implementation details and exposing only the necessary aspects of an object. It helps reduce complexity by allowing users to interact with objects without needing to know their internal workings. Now, let's see how these concepts work with Python code. In Python, you define a class using the class keyword. We'll create a basic class to represent a car. This class will have attributes like the car's make, model, and year, and it will have a method to display the car's details. The car class has a constructor method in it that initializes the object's attributes, make, model, and year. The method displayInfo prints the details of the car. When we create an object and provide car info, Python calls the init method and initializes the object with the provided values. The method displayInfo then prints the car's information. Let's see encapsulation in Python. Encapsulation refers to bundling the data and methods that work on that data within a single unit. It also includes the idea of hiding certain aspects of the data by making attributes private. You can make attributes private by prefixing them with 2 underscores. In this example, the attributes make, model, and year are now private, meaning they cannot be directly accessed from outside the class. To modify these attributes, we provide public methods like updateYear. This is how encapsulation helps in controlling access to the data. Now, let's see inheritance in Python. Inheritance allows one class to derive or inherit properties and behaviors from another class. Let's say we want to create a subclass called electric vehicle that inherits from the vehicle class, but with an additional attribute, battery capacity. In this example, electric vehicle is a subclass that inherits from the vehicle class, using the super function to call the parent class's methods. We also override the displayInfo method to add details about the battery capacity. This demonstrates the use of inheritance, where the subclass extends the behavior of the parent class while still being able to use its methods and attributes. Now, let's see polymorphism in Python. Polymorphism allows us to define methods that can be used interchangeably across different classes. Let's demonstrate this by using a drive method, which will behave differently for a car and an electric car. Here, both car and electric car have their own implementation of the drive method. Polymorphism is shown when we call the drive method on both objects within a loop. Even though we are calling the same method, the outcome is different based on the object type. Now, let's see abstraction in Python. Abstraction is about hiding unnecessary details and exposing only what's essential. In Python, we can use abstract classes to enforce abstraction. These are classes that cannot be instantiated on their own but can be inherited by other classes to ensure they implement certain methods. In this code, the vehicle class is an abstract class with an abstract method start. The subclasses car and electric car must implement the start method, ensuring that every vehicle class has a way to start. This is abstraction in action, hiding complex internal workings and focusing on the essential function that every vehicle should start. Object-oriented programming is a powerful paradigm that helps you organize and structure your code more efficiently. With object-oriented programming, Python allows you to create reusable, modular, and maintainable code. With this, the object-oriented programming section is complete. And finally, we'll talk about PEP8 naming conventions and some valuable code readability tips. First up, let's talk about PEP8. PEP stands for Python Enhancement Proposal, and PEP8 is the style guide for Python code. Think of it as the fashion guide for your code. It helps your code look good and fit in with other Python code out there. PEP8 covers a lot of ground, but let's focus on some key points. First is indentation. Use 4 spaces per indentation level, not tabs. This makes your code structure clear and easy to read. Next is maximum line length. Keep your lines to a maximum of 79 characters. For longer lines, use line breaks and indentation. This helps prevent horizontal scrolling and makes your code more readable, especially on smaller screens. Next is imports. Put imports at the top of the file and keep them separate. This organization helps others quickly see what dependencies your code has. Next are naming conventions. Now, let's talk about naming conventions. First comes function and variable names. Use lowercase with underscores for readability. Next are class names. Use camel case for class names. Next are constants. Use all uppercase with underscores for constants. Next are code readability tips. Finally, let's cover some general tips to make your code more readable. Use descriptive names. Don't be afraid of long names if they're descriptive. Add comments, but don't overdo it. Use comments to explain why, not what. The code should speak for itself. Use F-strings for string formatting. They're readable and efficient. Don't use old formatting methods. Embrace whitespace. Use blank lines to separate logical sections of code. Use list comprehensions wisely. They can make your code more concise, but don't sacrifice readability. Remember, these guidelines aren't rigid rules. The ultimate goal is to write code that's easy to read, understand, and maintain. Congratulations on completing our Python crash course. You've built a solid foundation from basic syntax to best practices. Remember, the best way to learn is by doing, so keep coding and exploring. Python's possibilities are vast and your journey has just begun. And finally, thanks for watching.